Okay, here are your notes on the polyatomic bonding. These here are coming from your yellow support sheet, which remember you will get on every single test or quiz, especially the final. But have these handy. Have these handy here for you. These are on your support sheet. Make sure you have that handy because not only does it give you the polyatomic, poly meaning many, atomic meaning atoms, and you can see these ions are made up of not just one but two different elements and sometimes multiple atoms of that element, and it holds a charge as itself. Okay? The nice part about polyatomics, the nice part about it is the naming is actually pretty easy. We don't change the names. We don't add any suffixes or prefixes. The hard part is making sure you have the charges balanced. However, that's also just very similar to what we do in ionics. Okay? One thing I do want to stress is this right here. This asterisk. Hypochlorite, chlorine, chlorate, perchlorate. I believe that's it. What this means, and right here, for the halogens, okay, your halogens, which is the group that starts with fluorine, which is funny because you don't do it for fluorine, this is except fluorine. So you've got bromine, iodine, chlorine, obviously, and acetine if you ever really use it. Okay, so except fluorine, but chlorine, bromine, and iodine. Chlorine's the example that's up here. Okay, these, the hypo and the ite, ate, and per all go. So ClO minus is hypochlorite. In that vein, if you have BrO minus, that's hypobromite. Okay, you see how the hypo and the ite stay, and we just change the chlor to the bro. Same thing, IO minus hypoiodite. Okay, so for those with the asterisks, you can insert bromine and iodine in there and just keep the beginning and the end, the prefix and suffix with that. Make sure you don't have to copy down this list, you have it, but make sure you copy down this and anything else you want to say about polyatomics. Okay, so let's do a couple examples. Potassium nitrate. First thing I look at, I find potassium. Okay, so I know that's K, and I look on my periodic table, which is also my support sheet, and I see that potassium is in column 1, group 1, so I know that's going to have +1. Nitrate, if I look at my support sheet, I find nitrate as NO3 minus. Okay, so potassium and nitrate, when I put them together, just like I do in ionics, I can do the cross. Okay, which means for every one potassium, I can balance it out with one nitrate, which is NO3, and I get KNO3. And that is a balanced, happy, polyatomic compound. Calcium hypochlorite. We're going to do the same thing. When you look at my periodic table, I see calcium, Ca, which is in group 2, so I know that's going to have a 2+. And then I go to my polyatomics, I look up hypochlorite. Hypochlorite is ClO minus. So in this one, again, I can do the crossover. I bring my 2 over here. I bring my minus over there. All right? And I get Ca. Only 1 calcium's needed. Now I'm going to put parentheses here. And I'm going to put hypochlorite inside the parentheses. And I'm going to put my 2 outside. And what that means is 2 of the whole polyatomic ion. Alright? If I can draw out, just like we did before with the ionics, I've got my Ca, 2 pluses here. I've got my ClO, my hypochlorite, 1 minus. Okay? And so just as we do the ionics, I've got a plus left. I need to add another ClO to cancel out those, and I end up with 1 Ca for 2 COs, and again that's written as 1 Ca here, 2 COs or ClOs here. Okay, that's calcium hypochlorite. Some things to avoid. I'm going to switch pen color here for you. Some things to avoid. Because all these are wrong. You don't need an extra set of parentheses. That's wrong. Avoid this, because that's a completely different thing. That's saying it's only 2 O's, not the whole thing. And then avoid this one as well. Oops, that should be down there. Avoid sort of distributing it through of Ca, C2, or Cl2, O2. Avoid that. These are all wrong. Okay, the blue is the right way. I'll put right over here. Okay. Going the other way, again, very similar. Okay, we just make sure we have balanced charge, and this is the nice part because we don't have to change any of the names. All right, so looking at this Cr2 SO4 3, and look at the parentheses there. So I look at my Cr, I go to my periodic table, and I see Cr is chromium, I believe. Let's find it. Chromium, column 6. So Cr, chromium. And then I look at my polyatomics, and I look for SO4. Okay? And SO4 is sulfate. And that's all I have to do. This compound is known as chromium sulfate. Okay? The reason there's a 2 here is chromium is actually a 3 plus, and sulfate has a -2. And so that's where you get this subscript and this subscript going the back ways. But going from formula to name, this is the formula, and this is the name. Okay? That's the formula. That's the name. Formula name is probably one of the easiest things. You just look at and make sure you have the proper anion and polyatomic cation. Okay? Oops. Ammonium bromide. Pause for a second and try this one if you want. Okay? I'm going to walk through this one here. Ammonium, now this one's a little trickier because ammonium is the cation. And we're not really used to seeing a cation polyatomic, but it happens. And this is the anion. Okay? So ammonium, if I look here, ammonium is NH4 plus. Bromide is just bromine. Okay, you see how we do keep the "ide" with the anion, which is just a single monatomic. Okay, so bromine of bromide, the ion is Br. And I look at my periodic table, I see bromine in group 7, and so I know that has a -1 charge on it. Ammonium bromide, I've got a +1, I've got a -1, and I know that those guys cancel each other out, so I can just write this as NH4, that's my ammonium, Br, that's my bromide. Try another one. Again, pause this if you'd like, try it. This one here is a little bit trickier because we got to start getting in the habit of picking it out. Now again, you'll have the support sheet, so you always have them, but as you start using them, you're going to get quicker and quicker at recognizing them. We're going to recognize this as just sodium, the Na, and then C2H3O2, you're going to start recognizing as acetate. Okay, so that whole thing is acetate. So here, sodium, and then this is acetate. Okay, so that is formula here, name here. If you want to go back just for fun, okay, sodium is Na plus because it's in group 1. Or excuse me, group 1. And then acetate, the C2H3O2. When you look on, you're going to see a sodium acetate. Acetate's got a -1. And so, just doing the cross, you need 1 sodium for 1 molecule of acetate, which again gives you NaC2H3O2. Okay, make sure your notes are marked up with this and be coming to class on Monday with questions.